Do you want to be a scientist?
Yes.
Yeah, we do.
Alright, well first the most fundamental part of science is learning the safety and math skills of it. Here's a guided lesson in order to figure out how every single part of the lab works. Every time you enter a lab, when you're working with dangerous chemicals, you always have to make sure you wear protective goggles and an apron. So make sure you guys wear goggles every single time. Basically, you just pull it back, wrap it around your head, and just let go and make sure it's tight. Okay, in addition, you also need to wear gloves at all times, practically at all times, depending on the lab. So what you need to do is you have to find your hand size. So mine would be maybe something like a large. You take the gloves out and just wrap it around your hands. And when you're done with the lab, make sure you dispose of them quickly and safely. One thing that you should always be wearing when in the lab is an apron. As you can see, we have a lot of aprons here, so there's plenty for everyone to go around. In addition, we have the fire blanket here, which if anybody for some reason catches fire at all, just pull it out and down, remove the fire blanket, and wrap it around the person that's on fire.
Can you use a fire extinguisher on people?
That's a very good question. No, you cannot. That is the purpose of this fire blanket.
Wow.
Here we got the first aid kit, which can be used when somebody is hurt in any kind of way. All you have to do is pull up and down once again, remove the first aid kit, and apply cautionary measures to anybody that needs it. Alright, here's the safety shower. Do you guys know what the safety shower does?
In case you're dirty.
No! Oh my gosh. Give me 10, give me 10. Come on, right now. You can't, no, just stay there, just stay there. Alright, the safety shower is for if any kind of contaminated material gets on to any part of your skin, then all you have to do is pull this down, water will come down, and it will seep through there, and you just have to wash yourself for 20 minutes. In addition, we have the eye wash station here, which if anything gets in your eyes, you have to just simply flick up, water will start to come out, and then you just use the water, apply it to your eye for at least 10 minutes. Alright, here we have the fire extinguisher, which can be used to put out any kind of fire when there is an object or something that shouldn't be on fire is actually on fire. So you just remove this, you take out the fire extinguisher, and we have an acronym for this, PASS. So you pull the pin, you aim the nozzle, you squeeze the handle, and you sweep from side to side. That's how you should be able to put out fires with fire extinguisher. Alright, this is the fume hood. Jacob, do you know what the fume hood is for?
Yes, I do. The fume hood is used to put CO2 and other harmful fumes into the atmosphere where they can be diluted.
Alright, Jacob. I see you. That was a good explanation. Sure, you take notes, please.
No thanks.
Alright, guys, can you explain the safety symbols and the safety diamond to me?
These are the safety symbols that you can find on substances. If you see this symbol, it means that the substance is harmful. This means that it's explosive. This means that it's corrosive, which means that it can destroy or damage other substances due to chemical action. This means that it's dangerous for the environment. Look at that fish. This means that it's flammable. It can catch on fire, as that shows. This means that it's toxic. Want to stay away from that. It means that it's radioactive. That means that it's a biohazard. And that means that it's an electrical hazard.
This is the NFPA diamond. It's used for each chemical. This shows the health hazard. This shows the fire hazard. This shows the reactivity hazard. These three are rated from 0 to 4, 0 being safe and 4 being the worst. And these are special things you have to worry about. Like, for example, this means use no water. And there are other signs that you have to watch out for too.
Alright guys, now it's time for me to teach you guys accuracy and precision. Are you guys ready?
Actually, we think we got this one.
Really? Okay, let's find out.
I'm gonna be precise, but not accurate. That was precise because they all went to the same place.
I'm gonna show accurate, not precise.
Shuri, the shots that you shot were accurate, but they weren't precise. Tell me why this is true.
That's because only one of them went in, and all of them didn't go in. So they were accurate, but they weren't close to each other, so not
This
precise.
is accurate and precise.
Alright, Shuri, why were my shots accurate and precise?
Because they both went in, all of them went in, so they were close to each other and they were close to the target.
Brilliant. Being precise is having all your shots go in the same general area as each other, but being accurate is actually getting the ball inside of the hoop. Alright, I'm going to teach you all how to measure precisely. Now, Shuri, tell me, What is the volume of water in this container?
Easy money, 70.
What about you, Jacob? What do you think?
That's 70.0.
Precisely, Jacob. It is in fact 70.0.
What's the same number?
It's called digit estimation tree, right? Depending on the scale of any kind of container, you always have to round, or give it a digit of estimation rather. So in this scenario, it's going by ones, therefore you always have to round to the nearest 10. Now just drop down and give me 20. Please. You're come on, buddy. No, okay, just stay there.
I'm done.
Alright guys, explain the metric system to me.
Well, it goes like giga, mega, kilo, hecta, deca, then the base, then deci, centi, milli, micro, nano, and pico.
But we also have a mnemonic to help you memorize that, because that's a lot of information.
Alright, let's hear it.
Great man King Henry died by drinking chocolate milk many nights past.
Nice. Alright, there's specific rules when you're counting sig figs. So the first rule that we have is demonstrated in the first problem, which is 12, 1, 2. First rule is that any non-zero number is always significant. So 1, 2, the above them are significant, therefore they have two significant figures. The next rule has to do with sandwich zeros. Zeros can be significant if they're sandwiched between two other numbers. In this case, it's 4 and 1. So 4.01 would translate to 3 significant figures. Our next example means that any non-zero number, no matter where it is, no matter if it's after or before a decimal, it is significant. So 0.123 would have 3 significant figures. Our next example has to do with scientific notation. You don't necessarily have to worry about the 10 to the power of 8 in this one. You just have to worry about the 6.02, which by our sandwich rule, it shows that it has 3 significant figures. Our final one has to do with zeros being significant. If zeros are trailing after the number, only when there's a decimal place, then they're significant no matter what. So since there are 3 zeros after the 1, then there would be 4 significant figures total. Alright, when you're actually applying these significant figures to actual mathematical equations, you can see our first equation, 3.75 plus 4.1 is equivalent to obviously 7.85. But it'd have to turn into 7.9 because the answer has to have the same amount of decimal places as the thing, in this case 4.1, with the least amount of decimal places. So that you only have to round it to the nearest 10. The same applies for subtraction because they're complementary to one another. In multiplication division, however, this rule is different. So you have 9.40 divided by 16, which is equivalent to 0.5875. But since 16 is only 2 significant figures, you have to take the least amount of significant figures and apply that to the answer. So that number turns into 0.59. Same applies for multiplication, as shown in the problem. 81.25 times 0.0014 is equivalent to 0.11375. But since 0.0014 has only 2 significant figures, it becomes 0.11. In order to understand the fundamentals of dimensional analysis, here's a given problem to help solve. So, the problem states, convert 3.4 days into seconds. So, the first thing that you can do is the thing that most people do when they're trying to calculate dimensional analysis, is you draw a table like this. In the end, it'll have all these numbers formatted, but let's just start with 3.4. So, we have 3.4 days. That's two significant figures. So, that means the final answer to this problem will have 2 significant figures. So, we have days here. So, we can, in order to turn days into seconds, we first need to turn into hours and minutes. So, we know that one day has 24 hours. So we can cross out the days here and the day here. So you have 3.4 times 24 over 1. But then you have to convert hours into minutes. So we know that there's 60 minutes in an hour. So you have an hour here, so we cancel the hours out and we have 60. Finally, you have to convert from minutes to seconds, and we know that there's 60 seconds inside of a minute. So we can just cross out the minutes and we're left with seconds. So now all we have to do is multiply the numbers on the top and divide it by the numbers on the bottom. Of course, on the bottom is 1 times 1. So essentially you just need to multiply the numbers on top. You do 3.4 times 24 times 60 times 60, which is equivalent to 293,760. But of course, you have to convert it to 2 significant figures. So that equate to about 290,000 seconds. Alright guys, you know how to convert from Celsius, Fahrenheit, and Kelvin to one another at any given time?
Yep.
Alright, let's see it.
So, to get from Celsius to Kelvin, you add 273 to the Celsius. And to get from Kelvin to Celsius, you subtract 273.
For Celsius to Fahrenheit, first you multiply the Celsius by 9/5, then you add 32. And vice versa, if you're given a Fahrenheit, you subtract 32, then you multiply by 5/9.
Alright guys, now for your next lesson. It's a fire alarm. What do you do, Shahiri?
Right here.
What about you, Jacob?
I'm gonna walk nicely.
That's good. Brilliant, Jacob. This is an evacuation procedure. You should never try to panic or anything. Just get out of the building as quickly as possible, but not in some kind of running or chaos fashion. I hope this video has helped you to become a better scientist.